Hi Year 11, it's Miss Jones here. I'm just going to talk to you a little bit about additional maths today, and we're going to start the first unit, which is on factorising quadratics. Okay, so additional maths is a level 2 qualification. At the end of it, you'll get a pass, merit or distinction. You'll do an exam at the end of the year like you would your GCSEs. It will be 2.5 hours long, 100 marks, and you'll be allowed a calculator on it. Okay. The things that they cover are algebra, trigonometry, coordinate geometry, mensuration and calculus. Okay, so the algebra is things like surds and indices, factorising quadratics, solving equations. Your mensuration is looking at area, volume and length calculations. Your coordinate geometry is looking at straight line graphs, looking at parallel and perpendicular lines, and looking at where they're going to cross curves. And then you've got trigonometry. You'll extend the trigonometry quite a lot in the additional maths, so you'll be looking at non-right angle triangles and also looking at the graphs of your ratios and seeing how they change and using trigonometric values to solve equations. The calculus is probably the thing that you won't have done any of in GCSE, and so it will be brand new. That looks at rates of change, and you do differentiation and integration to solve problems related to rates of change. You do an awful lot of that in your A-level, so it's really, really useful. Okay, so we're going to start with the algebra, okay, and the first unit is going to be on factorising quadratics. Okay, so in the factorising quadratics, we're going to have a look at factorising quadratics where the coefficient of x, so the number in front of x squared, is not going to be 1. We'll start off by looking at when it's 1, but then we'll move on to the quadratic equations where it's not 1. Okay, we'll also look at doing the difference of two squares, and we'll look at solving equations by factorising, and then we'll put all of those into context and solve problems with them, which is really the difference between GCSE and the additional maths, is being able to apply them a lot more. Just as a starter then, all I'd like you to do is find two numbers which multiply together to give the top number, so in this case 64, and which add together to give the bottom number, which in this case is 16. So I'm looking for two numbers which give a product of 64 and add to give 16. To start this, I would probably start off by listing the factors of 64. So I've got 1 and 64, 2 and 32, 4 and 16, 8 and 8. Now from that, I can see that 8 and 8, when I add those together, that's going to give me 16. So my answer on this one is going to be 8 and 8. Hang on, I've done that in highlighter. Have a go at the other ones, okay? I'll put the answers on in about 30 seconds, so pause the video so that you can have a go, and then the answers will come up. Okay, and these are the answers. If there are any that you're not sure about, please give me a message on Classroom and I'll explain how we've got them. Right then, let's have a look at factorising and expanding quadratics. Okay, so looking at this now, I have got two linear factors here. I've got x plus 5 and x plus 6. And I want to multiply out the brackets, so I want to expand the brackets. There's loads of different ways that you may have been taught this. The one way that I would start with is saying, well, I've got to multiply x by both of the terms in the second bracket. So I'm going to multiply x by the x first of all, which is going to give me x squared. Then I'm going to multiply the x by the 6. So I'm going to get plus 6x. Then I'm going to multiply the 5 by both terms. So I'm going to do 5 times the x. And then I'm going to do 5 times the 6. Looking at that now, the next step is I'm going to have to simplify. You can't add the x squared to either the x or the constant at the end, but you can simplify the two x terms in the middle. I've got 6 plus 5, so that's going to give me 11x. So my simplified answer is going to be x squared plus 11x plus 30. And expanding the brackets like that gives an awful lot of insight into how to factorise them. So factorising is putting them back into the brackets. I'm going to have a look at factorising the question underneath. What's the difference between this answer here and this quadratic here? Okay, yeah, it's that this is a plus and that's a minus, so it's going to give us a different factorised expression. So to factorise to start with, I'm going to start by opening up two brackets. Now from my expanded version, I know that when I multiply my first two x's together, that's going to give me my x squared, and we want the x squared there. So I'm going to put an x in each bracket, and I know that's going to give me my x squared. And then comes in the skills that you used in the starter, was saying, well, these last two numbers are going to multiply out to give me this end number here. And so I'm looking at the fact that this number is going to be obtained by multiplying this number by this number. Okay. And then when we multiply these terms, we're multiplying the 5 by the x and the x by the 6. And when we add those, that gives us our simplified version here. So we're looking for the two numbers that we're multiplying here to add together to give minus 11. So basically what we're looking for is two numbers that multiply together to give 30 and add or subtract to give minus 11. So we're going to go through our factors of 30. We've got 15 and 2, 30 and 1, 5 and 6. And I can see if I did minus 5 and minus 6, that will give me my minus 11. And so I'll put them into my brackets. Now, if you're not sure, you can then expand those brackets and check that you get the equation that they've given you there. So you know that you're going to get the x squared here, minus 5x, minus another 6x, so that gives you minus 11x, and then a minus and a minus is a plus to give you the plus 30. Okay, what I'd like you to do is pause the video and have a go at expanding out the two brackets here and then factorising this expression here. Okay, I'm going to give you the answers in a minute. Okay, hopefully you got that when you expand the brackets, you're getting your x squared plus 10x plus 3x plus 30. And when you simplified that, you've got x squared plus 13 plus 30. And then underneath there, the difference between the first expression and the second expression is the plus and the minus. And hopefully you've worked out that minus 15 plus 2 gives you the minus 13x, and you've factorised there. Okay, brilliant. We'll have a look at applying them now. Okay, could you pause the video please and then have a go at this exercise here. All you're doing is you are factorising this to go into there, and if you've been given the factorised version, you're then expanding and giving your answer there. Okay, so if you pause the video, I'll give you the answers in a second. Okay, and they're the answers. One of the most difficult things about factorising is having a look and knowing whether it's going to be a plus and a plus or a plus and a minus in the brackets. So just having a look at these examples, there's one of each on here. Now, the plus and the plus is probably the easiest example because there's no negatives in sight here. Okay, so we don't have to have any negatives inside the brackets. We're not multiplying to get negatives and we're not adding to get negatives. So there we can just look at positive factors. So positive factors of 6 that add up to 5, which would just give you the 3 and the 2. When you get onto the two negatives, okay, when I look at the negative at the end, I have to have multiplied a positive number by a negative number to end up with a negative. If I multiply two negatives, I'm going to get a positive. And if I multiply two positives, I'm going to get positive. So I must have to have one plus and one minus in this case. So that's what I'm going to start off with. Now, because I've got a negative here, I know that my negative factor of minus 8 is going to be bigger than my positive one because I've ended up with a negative number. So my factors of minus 8 being 4 and 2, it's going to be minus 4 plus 2 because minus 4 plus 2 gives you the negative 2. When I look at this one here, my negative and my positive, well, in that case, I'm looking at, in order to get a positive at the end, I must have multiplied two negative numbers together. So it's going to have to be two negatives in my brackets. So I'm looking at two negative numbers that when added together give you minus 9. So two negative factors of 18, it's going to have to be minus 6 and minus 3 would give minus 9. And then my last type is when I've got a positive and a negative. So like before, I know that if I'm going to get a negative product at the end, I'm going to have to have times a positive by a negative. So on there, I know I'm going to have one of each. But in this case, because I've got a positive here, it means my positive factor is going to be bigger than my negative one. So if I'm going to factorise that, I'm going to get positive 9 minus 2. 9 minus 2 gives me the 7. We're going to have a quick look at how your expressions and your quadratics relate to graphs. So all I want you to do, I'm going to just give you, these are your x values and these are your y values. You're going to substitute these x values into this expression to get your y values. Okay, so just substituting in here. On the first one, I've got minus 3, so x is equal to minus 3 squared plus 3 times minus 3 plus 2. So I would end up with y minus 3 squared, and minus times the minus is a plus, so I'm going to get positive 9. On here, 3 times minus 3 is going to give me negative 9, and then plus 2. So my y value for minus 3 is going to be positive 2. All I want you to do is finish the table for me. Okay, hopefully you got those values in the table. Once we've got the values in the table, we can plot the graph then. Okay, so I've got when x is minus 3, y is 2. So I'm just going to plot that one there. Then when x is minus 2, y is 0. The same with minus 1. When x is 0, y is 2. When x is 1, y is 6. When x is 2, it's 12. And 3 is 20. So I've got what's called a parabola there, your curve, which will be symmetrical. Have a look at the equation that you've got here and your curve and see what you can tell me about what you can get from the equation without actually having to plot the curve. You might want to start by factorising it. Okay, so the things that you might have looked for is you've got x plus 2 here and x plus 1, and the curve crosses the x line at x is minus 2 and x is minus 1. So you can see that those factors here are linked to where the curve is crossing the x-axis. What about where the curve is crossing the y-axis? It's crossing the y-axis at 2. If we look at this equation here, we can see that the end constant is 2. The reason for that is if x was 0, so 0 across, this would be 0, this would be 0, and y would be 2. So we can always see where the graph is going to cross the y-axis by this last constant here. See if you can work out which equation here matches this graph here. You might want to factorise them to work it out. Okay, when you factorise them, hopefully you will notice that all of them have got a factor of x plus 1, which is explaining the point where it's crossing the line here at x is equal to minus 1. If we look on the other side, it's also crossing the line at x is equal to minus 5. And so that should tell us that this is going to be our equation, because it's crossing the line at x equals minus 5, which is what would take this bracket to equal 0, and x equals minus 1, which is what would take this bracket to equal 0. What about this one? Can you see which of the equations on the left here would match this graph over here? Just pause the video and try and work it out. Looking at the factorised versions, then I can see that it is going to match this equation here, because it's got the minus 3, x is minus 3, which is what it will take this bracket to equal 0, and x is minus 2, which will make this bracket here equal 0. Okay, so on this one, don't be put off by the scale. If you look at here, it's going up to minus 2.5 in 5 small squares. So each small square is going to be minus 0.5. So here that's going to be minus 1, and that's going to be minus 6. So looking at that, I can see that my equation is going to be one of the ones with the 6 on the end, because when I multiply minus 1 by minus 6, I get positive 6. So I'm looking at one of these two equations, and it's going to be the one that has got plus 6 and plus 1 as your two numbers inside of the brackets. So which one is going to have plus 6 and plus 1? It's going to be this one here. And again, from the last one, we can see that we don't need to factorise them necessarily if we can do it in our head a little bit. So looking at these, I've got minus 3 and minus 1. I know that when I multiply those two together, it's going to be my end product that it's going to give me. So it's going to be one of those. So minus 3 times minus 1 is going to give me positive 3. So therefore it has to be this equation here. This one's asking you to actually sketch the graph yourselves. So it's telling you that it's given this equation that's factorised. So first thing, you need to work out which one of these equations it is. Then I want you to have a go at sketching the graph. When I say sketch, what that means is you don't draw all the numbers on the scales. All you're doing is showing where the graph crosses the x-axis, and if possible where it crosses the y-axis. Okay, so pause the video and just have a go at that, and then I'll show you what it should look like after. Okay, so the first thing I'm noticing is that I've got x plus 1 here and x plus 12 here. So I know it's going to cross the axes, the x-axis, at x is minus 1 and x is minus 12. I haven't done all of the numbers between minus 1 and minus 12 because on a sketch there's just no need. Okay. I know it's going to be a curve, and because x squared would be a positive x squared, I know that it's going to be going in this direction, so I can plot that out there. Now, from that, I can see that the graph is going to be this one here, because when I multiply my plus 1 and plus 12, I get positive 12. And I can also see from that it is going to cross the y-axis at 12, because when x is 0 in here, then y would be 12. So that would be a sketch of my graph y equals x squared plus 13x plus 12 without having to plot all of the values. Have a go for me at just joining together each of the equations here that are equivalent, and then have a go at sketching the graph of those equations as well. Okay, the answers are there for you there. So you matched up all of the equations and then the graphs are on the right hand side there. We're going to have a look at the difference of two squares now, which is just a slightly different method of factorising. If I looked at expanded these two brackets here, I would multiply my x by x to get x squared. Then I would have minus 2x. When I multiplied my 2 by both terms, I'd have my plus 2x and then my minus 4 on the end. And you can see that in the middle, these terms are going to cancel each other out. So I'm not going to have an x term at all. Now that would only work if I've got a plus and a minus inside that bracket. And that's what's called the difference of two squares. So if I go to factorise, going the other way, I would have a look at this and say, well, I know that I'm going to have my two brackets because I've got two square numbers there and a negative in between. The fact that it's negative in between is really important. It wouldn't work with a positive because I would never end up with a positive here and be able to cancel these two out. So it's always going to be a negative here. So all I would do then is square root the x, because I'm going to have an x in each one, and that's going to give me my x squared. And then square root my 4. Square root of 4 is 2. And then in order to get rid of my x terms, I'm going to need 1 plus and 1 minus. And that is just what the difference of two squareds is. When I come to this one here, I can see that actually the 2 is not a square number and neither is the 8. But they have a common factor of 2 that when I divide by it, I'm going to get the difference of two squares. So the first thing I'm going to do is divide by my common factor of 2. And then I can see I've got the difference of two squares here. So I can expand this one out by doing exactly what I have done before, and I would end up with two lots of x plus 2, x minus 2. Have a go for me at the your turn questions on the right hand side and see how you get on. Just pause the video and the answers will come up in a minute. Okay, you should have got pretty much the same, except the square root of 25 is 5, and so you've got x plus 5, x minus 5, and underneath you're dividing by a common factor of 2 again. Have a go at the intelligent practice questions, so pause the video. I'm going to show the answers afterwards, and again, if you're stuck on any, just ask me on the classroom and I'll explain any of the answers. Okay, and there are your answers there. Okay, the last thing that we're going to have a look at is solving quadratics by factorisation. So when we're doing this, we're looking at the fact that anything multiplied by 0 gives us 0. So if I've got my equation in the form of this, x times by x minus 8 is equal to 0, I know that if any one of these, the x or the x minus 8, is 0, my whole answer would be 0, because anything multiplied by 0 is 0. So I've got two options here. I could say that either the x is equal to 0 or the x minus 8 is equal to 0. And I know that I should get two options because it's a quadratic and we've looked at the fact that it's a symmetrical curve which gives us two solutions. So we've got the x equals 0, that's all done. So on this side now, x minus 8 equals 0. If I solve that equation and add 8 to each side, I get that x would have to be 8. So in order for this equation to be true, either x is 0, and then 0 times minus 8 would be 0, or x would be 8, and 8 times 0 would be 0. And we've solved that equation then. So when we've got two brackets, it's exactly the same principle. Either x minus 2 is going to be 0, or x plus 3 would have to be 0. Now in order for x minus 2 to equal 0, x would have to be 2. And for this to equal 0, x plus 3, x would have to be minus 3. And they are my two solutions to this equation. Looking at this example here, it is a little bit more difficult because we are going to end up with fractions. However, it's exactly the same principle. Either 2x minus 5 is going to equal 0, or x plus 1 is going to equal 0. Now the x plus 1 is easy enough. X would have to be minus 1 for that to equal 0. This side is a little bit more complicated, but it's just an equation for us to solve. So all I would do is add 5 to both sides, so I'd get 2x is equal to 5, and then divide by 2. So x is equal to 5 over 2. And I could leave it as a fraction, or I could simplify it to 2.5. It doesn't matter either way. Have a go at these questions, pause the video, and then the answers will come up in a few seconds. Okay, so just pause it and have a go. Okay, here are the answers to the first section. If you just mark those ones. Okay, and then answers to the second section. The extension question, question 2, is a lot more difficult than just the expanding or the factorising. Looking at this now, we are going to have to try and get rid of the fractions here. So if I want to get rid of my denominators, I could times everything through by x minus 1. If I times this fraction through by x minus 1, I just end up with x minus 2. Because I no longer have the x minus 1. If I times this fraction by x minus 1, I'm going to end up with x plus 4 times by x minus 1, and I've still got this denominator here. Now I'm going to multiply through by the 2x plus 2. If I times this fraction by 2x plus 2, the denominator is just gone. If I multiply this by 2x plus 2, I'm going to end up with 2x plus 2 multiplied by x minus 2 is equal to x plus 4 times x minus 1. Now, I'm not going to be able to solve that because I need the equation to equal 0. and so I'm going to have to expand out the brackets and then simplify. Expanding out this bracket, I'm going to get 2x squared minus 4x plus 2x is going to give me minus 2x, and then 2 times minus 2 gives me minus 4, and that is going to equal x squared minus an x plus 4x. That's going to give me plus 3x. 4 times minus 1 gives me minus 4. And then it's an equation that I can solve. I'm going to take an x squared off both sides. So what I end up with then is 1x squared on this side, and this stays the same. This side, the x squared is gone, so I've got 3x minus 4. Okay, the next thing I want to do is move the 3x onto the left-hand side. So I'm going to subtract 3x from both sides of the equation because I want to end up with a quadratic is equal to 0. So when I take 3x off both sides, I'm going to get x squared minus 5x minus 4 is equal to minus 4. And then I want rid of that minus 4, and so I'm going to add 4 to both sides. And what I'm going to end up with is x squared minus 5x is equal to 0. Now that's a quite nice one for me to solve because it's not going to give two brackets, it's got a common factor. So if I factorise x squared minus 5x, I'm going to get x multiplied by x minus 5. And in that case, x would have to equal 0 or x would have to equal 5. And I can always go in to my original question and check that that works out. If I was going to do that, I would say I've got, if x was 0, minus 2 over minus 1 is equal to 4 over 2. Now the negatives cancel out. 2 divided by 1 is 2, 4 divided by 2 is 2, and therefore we know that we've done that right.